Finally don't have COVID, and I'm super hype. And first of all, I'd love to say thank you and good job to everyone who was on my team during the CTF. This is our first CTF participating as a team together. We played as equivalent exchange, and I'm super proud of everyone who participated. We had a member count of like 8 during the CTF start time. Started Friday, ended Sunday. We were like top 3 for a while, and then point DK, and we slowed down, couldn't solve some chows, and whatever. But, we did really good. We finished like 12th, not bad. And yeah. In the beginning of main, there are less than 2 arguments that'll print out the usage. Else, we have this file data void pointer, gets f-readed, and it takes the in file. You drop into this for loop. It does pointer calculation to point to the next 4 bytes each iteration. Then rotate left value by 13 bits and write it to data. And then it'll f-write out to argv2, which is the out file. It'll write the file data to argv2, and it'll exit. So we do see here that Binja created this little macro, which is just a rotate left instruction. So let's take a look at the solution. So we have 2 functions here, a rotate right function and decrypt flag function. Rotate right function will rotate a value by set number of bits. Decrypt flag will decrypt our flag. We read in the encrypted file, we create a byte array, then we make a for loop that'll read 4 bytes at a time. We decrypt it block by block, rotating each block 13 bits, and then converting back to bytes and appending it to the decrypted data, which is the byte array. And then it'll write it out to a file. And when we run it and then got it, we got the flag. So this will be a little series where in between videos or at the end of videos, I'll drop some random reverse engineering tips that you can take or not, or maybe you learned something that you didn't know, and hopefully it can be added to your skill set. So initially, when opening this binary, it's basically unreadable. It's doing some like in-house hacking and whatnot. So in order to resolve this, we will open the binary in GDB, and we will basically dump memory. So now that we have it open in GDB, we run, just fuck with it, and then VM map, memory. We're gonna dump from here to here. And now that we have this new .bin, we'll open it in Binja. And we'll just give it a minute to load. So looking through, we now have things that are actually readable, right? Okay, so now I'll show you how to resolve these got functions. You just click through that. And this is the offset from libc. So we do need to rebase, and that is something that I didn't show you. So I'll quickly show you how to do that. So you remember that we jumped from here to here. So this will be the base. And if we go back, boom. And we just do this. Telescope it. Grab what it's pointing to. X info on it. And then we open up. See? This is also going to take a second to load. So let's copy the offset. So this is calling index. So you can go back here and call this index. And let's do this one here. Actually, it's just a puts wrapper. I mean, I guess we can just same thing. Yeah, just an F puts wrapper. And basically you'll just do the same for the rest of it and just resolve entries just like that. And eventually you'll have something like this, which you can actually read.